Next, I'll begin with explaining how many possible combinations you could do with the cube. So you can move it front or back. This would count as a combination. This would count as a combination. Anything that changes from the solved position would count as a combination. So first we could start off with the centers. The centers stay the same. So you'd have 1. Then you would start with the edges. You have 4, 4, 4, and then another 4. You'd have 12. So it'd be 12 factorial. Why? Because you could move this edge right here anywhere on the cube. So you could have it anywhere on the cube, and then there's 11 other places where the second piece could be. So it'd be from like 12 times 11 times 10 times so on. And then the next part would be doing the corners. You have 4 in the top, 4 in the bottom. You have 8, so you'd have 8 factorial with the same reason as the edges. You have 1 corner, and then the rest of the pieces you could just continue adding them. Next thing that comes into play would be the different ways you could arrange the edges. The edges could be in 2 sides, like this one. 2 sides. So you'd have 2 to the 12th power. Why? Because you have 12 pieces that could be arranged differently. Next thing would be the corners. So you have 3 different ways you can arrange them. So 3 and then to the power of 8. So you have a total of 8 pieces. And then you would want to divide this by 3, because there's a few possible scrambles where, like, let's say this piece is turned, you can't solve that. And then same thing goes with the other 2 sides with the corners. And yeah, it's not possible to solve them. And then that gives you a total of approximately quintillion. If I actually do the math, it's gonna be a really big number. So it would be it would be 3. So it'd be 43 quintillion, 250 quadrillion, 3 trillion, 274 billion, 489 million, 56,000 possible combinations. And that's the amount of permutations you could do. So combinations of how to mix it up, and that's a lot.